All right, section 8.5 is all about solving by substitution. Now again, what we are solving are these systems of equations. We saw in our last video how to solve systems of equations by graphing them and finding where those two lines would cross. But on this one, we're going to use substitution, which means we don't have to graph anything. We're just plugging things in numerically. So why would we use substitution? It's to find that point, that ordered pair. Again, it's like our XY spot where the two lines would cross. That's considered our system or our solution to the system. And we can do substitution because it's better than graphing it. It'll find an exact solution. Sometimes our graphs won't show us an exact spot. Maybe they'll cross in between 2 points or like 2 2/3 or something like that. Solving by substitution, you can always find an exact spot. So the process of this is we solve one of the equations for one variable. So one of the equations, not both, just one of them, you either get it to say x equals something or y equals something. Then you use that equation and plug it into the other one. You replace that expression for that variable in the other equation. You solve for that one variable, then you substitute that value into either of the original equations to solve for the other variable. The answers are considered ordered pairs. So again, your answer would be whatever that x value was, and then the y value, x equals something, y equals something. And again, it just means this is the spot where the two of them cross. Now you can check your answers then by substituting the x and y value into both of the equations, and both of them should come out true. So let's see how this works. If we've got two equations, so our system says y equals 5x minus 2 and y equals 5x minus 4. Now notice that both of these equations already have y alone. So I would just replace this 5x minus 2 everywhere I see a y. So down here I see a y, I would just call it 5x minus 2 equals 5x minus 4. So we're literally just replacing y into the other equation. So 5x minus 2 equals 5x minus 4. We're going to subtract 5x from both equations, and we'll get it to say negative 2 equals negative 4. Now, if you end up with a true statement like 5 equals 5, then these equations are actually the same exact equation, even though they might have been written differently. This means in the end that there would be infinite solutions because they match everywhere. That's just like when we graphed the equations and the two lines were right on top of each other. We'd say infinite solutions because they're the same line. If you end up with a false statement though, like negative 2 equals negative 4, what we got, then the equations would actually be parallel and they would never cross each other. Again, like when we graphed and we saw the parallel lines. You would say that there are no solutions. Now these ones we can actually see. Y equals 5x minus 2 and y equals 5x minus 4. Those would graph out to look something like this. We'd go to minus 2 and we go to minus 4. This one would look something like this. This one would look something like this. They would be parallel. They would never touch each other because they have the same slope, 5. So we would just simply say this is not true. Negative 2 is not actually equal to negative 4, so there are no solutions. In this first case, we found a no solutions kind of system. There's no time or no spot where these two lines will ever cross. So let's use a new system then. 3x plus y equals 1, and y equals x minus 3. Now we lucked out on this example. We've already got one of our variables, y, all by itself. So we've already set it equal to something on its own. So we can just simply plug in that value of y, or this piece, in for y up here. So our equation would now say 3x, right here, instead of plus y, we're going to be adding on what y equals. Y is actually equal to x minus 3, so we just replace x minus 3 right here where that y value was. So 3x plus x minus 3 equals 1. It's the same as the top equation was before, we just replaced whatever y is equal to. So simplifying that, we kind of get rid of those parentheses because we're adding everything in there. We don't need the parentheses. So 3x plus x minus 3 equals 1. We can combine those x values 3x plus 1x is 4x, so 4x minus 3 equals 1. Add 3 to both sides, and we would get 4x equals 4. Divide by 4 on both sides, and we get that x equals 1. So we know that the spot where these two lines are going to cross, our x value is going to be 1. What we do with that then is just simply plug that value into one of our equations. And it doesn't matter which one, just one of the original ones. I'm going to use this one, where y is already by itself. So we just plug in 1 wherever we see an x. So y equals, instead of x, 1 minus 3. What is 1 minus 3? Well, it's just simply negative 2. So y has to be negative 2. So our solution is the spot 1 comma negative 2. Or you can say the solution is x equals 1, y equals negative 2. They mean the same thing. This is the point on the graph where both of these lines will cross. Or again, if you wanted to check, you plug in 1 for x, so 3 times 1 is 1, or sorry, 3 times 1 is 3, plus, instead of y, it's negative 2, so 3 plus negative 2 equals 1. So that's true. Let's try the same thing down here. Instead of y, we say negative 2 equals 1 instead of x minus 3. Well, 1 minus 3 is negative 2. So this one is true. So in both of these equations, this spot where x is 1 and y is negative 2, this is true for both of these equations. So this is what we would call the solution. Let's find the solution for this system. Again, y is already alone, so all we have to do is plug it into this equation. Now this one, it's a little bit longer. The bottom equation says 4x minus 4y. So when we replace y with all of this, we still have to have that 4 on the outside. So this 4, or technically, we have to think of it as a negative 4, because there's minus here. This negative 4 gets distributed to all of these. So negative 4 times negative 8x, negative 4 times negative 11. And it's still said all equal to 8. So as we distribute that, it would say 4x plus 32x, because negative 4 times negative 8 is positive 32. And in the end, plus 44, because negative 4 times negative 11 is positive 44. So 4x plus 32x plus 44 equals 8. Combining any like terms, we'd get 36x plus 44 equals 8. Subtracting 44 on both sides, we get 36x equals negative 36. And dividing by 36 on both sides, we'd get x equals negative 1. Using this, x equals negative 1, and just plugging it back into one of our original equations, I'm going to use the top one, where y is already alone. Everywhere we see x, we just plug in negative 1. So negative 8 times negative 1, and then minus 11. Well, negative 8 times negative 1 is positive 8. So positive 8 minus 11 equals y. So y, we would say, is equal to negative 3. So this is our solution. Again, you would write it out as negative 3. This is the point that they both go through. Or you could just simply say the solution is that x equals negative 1 and y equals negative 3. This is the only spot on the graph where these two lines will cross each other. All right, here we've got 8x plus y equals 23 and negative 8x plus 3y equals 5. Now, we're going to need to rearrange this top one first before we can plug it in to the bottom one. So we would subtract 8x from both sides, and we'd have y equals negative 8x plus 23. Now that we've rearranged everything, now we can plug y into this equation. Now sometimes, this example didn't necessarily do it yet, but sometimes there might be a number in front of y. So this would say maybe like a 2y equals all of this. To get rid of that, again, you would just divide by 2 on both sides now to get y alone. The trick with this is always just to get one of the variables completely alone. In this example, it happened to be y that we're getting alone, so that you can plug that into the other equation. So as we plug it in, it now says negative 8x plus 3 times all of what y equals, y equals negative 8x plus 23. So we plug it in right here, and then all of that equals 5. So because it's 3 on the outside, we have to distribute it to all of these pieces. What we'd be saying then is negative 8x minus 24x plus 69 equals 5. Combining any like terms, we'd have negative 32x plus 69 equals 5. Subtract the constant on both sides, so minus 69, and we'd get negative 32x equals negative 64. Divide by negative 32 on both sides, and we'd get x equals 2. So we know x equals 2 is going to work in both of these equations, and it's going to give us the same y value. So let's plug it into, it doesn't really matter, I'm going to plug it into the top one. Instead of 8 times x, it's now 8 times 2 plus y equals 23. 8 times 2 is 16, so 16 plus y equals 23. Subtract 16 on both sides, and we get that y equals 7. So those are our solutions, or that point is the solution. These two lines are going to cross at 2, 7. That's our xy coordinate of the spot where these two will cross each other. It's at the spot 2, 7. Now we can also do these with word problems. Now word problems get a little bit trickier because you have to make the system from what they tell you. So step 1 is you're going to read the question. Step 2, you're going to define your variables. Step 3, write the two equations that relate the variables to some quantity. Then you're going to solve the system using substitution and check your work by substituting. So let's look at an example here. You are on a submarine tour that passes a group of scuba divers and octopi. That's plural of octopus. There's many octopi instead of just one octopus. So you count 27 heads. Each scuba diver has one head and each octopus has one head. And you count 126 legs. Each scuba diver will have 2 legs. Each octopus will have 8 legs. How many divers and how many octopi are there? So you should be able to tell if there are 27 heads and 126 legs, you should be able to figure out how many divers and octopi there actually are. So first things first, we need to define our variables. We'll say x is the number of people, or the number of divers. Y is the number of octopi. So we have our definition of each of our variables then. Now we need to make our system of equations by creating the equations that would relate all of these variables and all of the quantities together. So if there are, so many number of people and so many number of octopi, and again, each one of them only has one head, then we would say x plus y equals 27. If there are 3 people and 4 octopi, 3 plus 4 equals 7 heads. So x plus y equals 27 number of heads. Now if each person has 2 legs and each octopus has 8 legs, we would start off by saying 2 times the number of people plus 8 times the number of octopi would be our total amount of legs. And we are told that the total amount of legs is 126. So we can get rid of that and just say this is our system of equations. X plus y equals 27. 2x plus 8y equals 126. Now is where we need to get one of our variables alone. Now this equation is set up nice and easy for us to look at and say, well, either we can get x alone or y alone. It doesn't matter which one because they both have a coefficient of 1 in front of them. So it's really easy to get it by itself. In this equation, if we tried to get x alone, we'd have to divide everything by 2. If we tried to get y alone, we'd have to divide everything by 8. But in this equation, they both just have a 1. So let's get x alone, and we'll subtract y from both sides. So we'd say x equals negative y plus 27. Now, using this as our value of x, this expression, negative y plus 27, will replace every time we see an x in the other equation. So right here, gets replaced with this amount. When we do that, it now becomes 2 on the outside times this amount, negative y plus 27, plus 8y is still there, and it all equals 126 still. So we just simply have to start simplifying these expressions. 2 distributed over to a negative y is negative 2y. I'm going to show you what's happening there. We're distributing this and this. So negative 2y plus 54 plus 8y equals 126. So then we just combine like terms. Negative 2y and 8y make positive 6y plus 54 equals 126. Subtract the 54 from both sides and we get 6y equals 72 because we subtracted 54 from both of them. Now divide both sides by 6 and we would get that y equals 12. So part of our solution is already done. We know that y equals 12. We bring it back up here. We plug it into either one of these equations. I'm going to do this one just because I think it's going to be a lot easier. We don't have to worry about multiplying stuff. So as I plug it in, everywhere I see a y, I just replace it with 12. So x plus y is now x plus 12 equals 27. Subtract the 12 from both sides, and I would get x equals 15. So that's going to be my solution. Y is 12 and x is 15. Now let's go back to our definition though. X is the number of people, y is the number of octopi. So we would say that there are 15 people or 15 divers and that there are 12 octopi. And again, we found that out by setting up our system of equations, getting one of our pieces all alone, replacing it and solving for one variable, and plugging that in and solving for the other variable. So that was our systems of equations, solving them with substitution. And that'll be it for that video.